Welcome to the Lido RouteManual Standards tutorial, Approach Minima. Today we'll have a closer look at the landing minima section of an instrument approach chart, which we briefly described already in the instrument approach chart tutorial, but we'll also have a look at the takeoff minima. But first, let's focus on the landing minima. The landing minima section of an instrument approach chart shows all procedure relevant lowest permissible landing minima for the approach depicted in the chart plan view. The information is displayed in an easy-to-use table found under the profile of each instrument approach chart. As a standard, Lido publishes minima according to EASA regulations. However, charts which contain minima calculated to TERP's design criteria will be labeled with flags. Straight in and circling will be flagged independently. When there is insufficient space on the chart for all available approaches to be shown clearly, a minima overflow chart will be available. To indicate that there is a minima overflow chart related to this procedure, a black arrow will be displayed at the lower right side of the minima table. The general cabinet of the minima table will display the approach runway designator in the runway box, TERP's flag, if applicable, also in the runway box. Please note the flag in the runway box is denoting straight-in procedures only. Straight-in and circling design criteria are flagged independently. The minima table will also display aircraft category or aircraft type in the aircraft box and measuring units in the unit boxes. The minima are depicted in sequence, starting from the best approach with the lowest landing minima possible at the left to the approach with the highest minima to the right. Please note that where Cat 3B is possible, the Cat 3A minima are omitted by intention, as long as the Cat 3A approach is to be used with the standard approach minima of down to 0 feet decision height and 200 meters RVR. In the US, 0 feet decision height and 700 feet RVR. Where higher minima have to be applied, these would be shown. Simply apply standard Cat 3A minima as provided in your airline OMB or AOM for the respective aircraft operated. The system line shows the main type, the classifier where applicable, and subtypes of the approach A to be used. For all precision approaches, instead of the main type, the classifier, for example Cat 1, is shown. The description line is used to bring additional information concerning the approach forward. This information may or may not be accompanied or further explained by a note in the notes section. Minima relevant notes will be shown as required, always underneath within the notes section of the minima section. As seen previously, chart flags are used to display information. Others that are used are TERPs, minima calculated according to TERP's design criteria; LTS, minima contains RVR and or visibilities calculated for lower than standard ILS Cat 1. OTS, minima contains RVR calculated for other than standard ILS Cat 2. Please note that OTS values will be published only if the approach is the lowest permissible or when requested by your company as a tailored chart. EVS, minima contains RVR and or visibilities calculated for enhanced vision systems. Please note that EVS values will be published solely as a note to the ordinary minimum unless requested as an additional EVS minimum in a separate cabinet on a tailored chart. The weather line serves two purposes. It shows ceiling and visibility. In absence of required ceiling, the decision height or minimum descent height is shown. Heights and ceilings are shown together with the vertical sight requirements. Ceiling values are prefixed with C, measured RVR as a suffix of R, and visibility that cannot be converted is suffixed by V. The operation line provides information about the applicable minimum value. The values stated here are the governing basis for decision making. It shows minimum descent altitude for non-precision approaches, decision altitude for Cat 1 approaches, and radar altitude values for Cat 2 or Cat 3 approaches respectively. The term company is added for Cat 3 approaches where no decision height is published and a radar altitude can't be stipulated. Now let's have a closer look at takeoff minima. The takeoff minima is published in the departure section of the AOI of the RouteManual. The values are calculated according to EASA OPS, but any higher source given value will take precedence over the calculated minimum. Runways are displayed in ascending order. Aircraft categories will be displayed alongside the minimum value units. Minima are shown with a ceiling value first, with RVR and/or visibility after. Climb gradients, when published by the state and when it exceeds 3.3%, will also be shown. Please note that ATC climb gradients will not be displayed. Where more than one takeoff minimum is published, the additional takeoff minimum and its dependent climb gradient will be displayed when no climb limit is stated, a continuous climb above 1,500 feet above airport level is required, the climb gradient is 7% or more, the aerodrome elevation is more than 5,000 feet above mean sea level, an omission of the takeoff minimum climb gradient would cause an operational impact. Where takeoff minima are related officially to specific or all standard instrument departures at an airport, or if the minimum is the same for all standard instrument departures within the takeoff minima table, the takeoff minima will be displayed together with the standard instrument departure designators. Minima for failed or downgraded ground equipment will have to be derived from separate tables integrated within the rules and regulations sections of the Lido general part of the Lido RouteManual. This is the table for EASA minima. To use this table, simply locate the applicable approach type at the top of the table and the equipment failure or downgrade on the left-hand side. Then read off the change to the minima which need to be implemented. In this example, the user is flying a Category C aircraft on a Cat 2 ILS into London Gatwick during the day, and the runway centerline lights, RCLL, has been downgraded. The user will open the table, find Cat 2 approach at the top of the table, and read down to the RCLL row. There are two sections, one for day and one for night. As this approach is during the day, the RVR has been raised from 300 meters to a minimum of 350 meters. Please be aware of any additional information of changes provided by numbered references. A further example of this can be found in the Rules and Regulations section 821. Separate tables for U.S. and non-U.S. operators when operating within the U.S. are found within the United States Country Rules and Regulations section, CRAR. This table is for U.S. operators operating within the U.S. Simply locate the applicable approach type and the inoperative component and increase the visibility accordingly. In this example, the user is flying a Category C aircraft on a VOR approach and the P2 visual aid has failed. The user will open the table, find the VOR approach type section, identify the P2 visual aid, and confirm the aircraft type C. Then read off how much to increase the visibility. In this case, the visibility will need to be increased by a half statute mile. Please be aware of any additional information of changes provided by numbered references. This table is for non-U.S. operators operating within the U.S. Again, simply locate the applicable approach type at the top of the table, the aircraft category, and the equipment failure or downgrade on the left-hand side. Then read off the change to the minima which need to be implemented. You may be referred to a Table A for high-quality approaches, these approaches fulfilling the criteria as stipulated by EASA, or Table B for low-quality approaches. These approaches do not fulfill the mentioned criteria, where you will need to compare two minima values and use the higher one of the two. In this example, the user is flying a high-quality RNAV GPS approach with VNAV capabilities in a Cat D aircraft. The all operative values in the minima section are showing a decision height of 760 feet and a visibility of 2.25 statute miles. The installed approach light to the landing runway, a P1, has failed. The user will then open the table for non-US operators in the US, find the RNAV-VNAV approach at the top of the right-hand high-quality table, confirm the aircraft approach type, D, and read down to the P1 approach light unserviceable row. From this box, the user is to increase the original all-operative visibility value, 2.25 statute miles, on the chart by 0.5 statute miles, resulting in 2.75 statute miles, or use the corresponding value in Table A, whichever is higher. The corresponding value in Table A is found by using the current decision height, minimum descent height value of 760 feet, and reading down to the value range. Then read across to 1.5 statute miles. As this is less than 2.75 statute miles, the visibility to be applied is 2.75 statute miles. Please be aware of any additional information of changes provided by the numbered references. Let's have a look at another example. Let's assume we are dealing with a low-quality NDB approach. The aircraft is a Category D, minimum descent height is 490 feet, and the visibility on the chart is 4,300 RVR. Find in the right-hand table 1,600 feet to be added to the original visibility value when the approach light system P1 fails. That equals 4,300 plus 1,600 equals 5,900 feet. The current value in Table B is found by using the current minimum descent height value of 490 feet and reading down to the value range, then read across to the RVR to find 6,000 feet. As this is higher than 5,900 feet, keep in mind original 4,300 feet plus increase of 1,600 feet, the 6,000 feet RVR from Table A must be used. Please be aware of any additional information of changes provided by the numbered references.